Hello, everybody. Off we go to chapter 13. Labor. So it's the labor market that we're looking at in this chapter. Oops. Okay, so in chapter 13, we look at the profit maximizing quantity of an input that a firm should purchase, and we're going to see that there's the same principle applying in the input market that applied in the output market. The profit maximizing quantity of input a firm should purchase is the quantity corresponding to the point where marginal revenue product equals marginal factor cost. So it's marginal revenue and marginal cost equaling marginal cost, the same principle that we saw in the output markets. Okay, so secondly, we look at the shape of the input supply curve facing an individual firm in a perfectly competitive market versus the shape of the supply curve for the industry as a whole. So what we're going to see is that in a perfectly competitive input market, the supply curve facing the individual firm is perfectly elastic, otherwise known as horizontal. And for the industry as a whole, the supply curve of the input slopes upwards to the right. And then we look at some of the goals that labor unions have because they control the labor supply to certain firms, and some of the impacts of labor unions in the labor market. And then finally, we'll look at the effect of a so-called monopsony on labor market price and quantity of labor purchased. A monopsony is a single purchaser of an input or a product. Okay, so oops, in chapters 9 through 11, we looked at the profit maximizing quantity of output that a firm should produce, and we came to the conclusion that the profit maximizing quantity of output was the point where marginal revenue equaled marginal cost. And this was the rule in 3 of the 4 industries we looked at: perfect competition, monopoly, and monopolistic competition. So in chapter 13, we look at the profit maximizing quantity of input that the firm should purchase, and we're going to see a similar principle applying. The profit maximizing quantity of input the firm should purchase is the quantity corresponding to the point where marginal revenue product equals marginal factor cost. So it's marginal revenue equals marginal cost, same principle that applied in the output markets. So what we're going to see is that the marginal revenue product is simply a formula of the output product price multiplied by the marginal physical product. And the marginal physical product is the additional quantity of output the firm can produce by hiring one additional unit of input. And of course, the input in this example in the chapter is labor. So in the book, the additional unit of labor is one additional week of, or one additional person working an additional week. Okay, so here's our formula. The so-called marginal revenue product equals the price of the output times the additional output that's produced by hiring one additional unit of input. And yeah, that's our rule. That's our rule. Okay, so now we're going to walk through this example to illustrate that principle. So in our little data table here, we have on the left-hand column, we have quantity of input. So here we're starting, we have 6 workers per week, 7 workers per week, 8 workers per week, 9 workers per week, and so on. So as we hire our additional workers, their total physical output, the total quantity of output they produce increases. And then the marginal physical product is the difference in total output from hiring each additional worker. And we see that marginal physical product stays positive, but it declines. So it increases, but at a decreasing rate. And then we calculate our marginal revenue product, which is simply the product. So marginal revenue product equals marginal physical product multiplied by the output price. And in this example in the slide, our output price, the price of our output, or CDs, is $6 per CD. So to get our marginal revenue product, we simply multiply the marginal physical product by the output price. And in our final column here, we have our marginal factor cost. And our marginal factor cost in this example, so the marginal factor cost is the wage rate, and it's expressed on a weekly basis here. And in this example, it's $498 per week. So what we can see from this little diagram is in this, when our number of units of input are less than 11, our marginal revenue product exceeds marginal factor cost. So here, as we hire additional units of labor, when we go to 6 to 7, our marginal revenue product is $708 per week, and our cost of the additional worker is $498. When we get up to 11 workers, the marginal revenue product for the additional worker is $540 per week, and the cost of that additional worker is $498. So when our number of units of input is less than 12, our marginal revenue product is greater than our marginal factor cost, so we can justify hiring additional units of input because it's going to increase our bottom line. So our marginal revenue exceeds marginal cost in this section here. And when we hire more than 12 units, we see that our marginal factor cost exceeds our marginal revenue product. So 498 is greater than marginal factor cost is greater than marginal revenue product as we use more than 12 units. And so again, we can increase our net income by reducing our use of inputs because our cost exceeds our revenue. So we can reduce our losses by using less. And that pushes us to this equilibrium point where the optimal quantity of input we should hire is the point where marginal revenue product equals marginal factor cost. And in this example, it's $498 per week for each. Okay, so our marginal factor cost, as we just mentioned, this is the wage rate. In this example, using labor, the wage rate per week. And in the example we just looked at, it's $498 per week. Okay, so our formula for marginal factor cost is change in total cost divided by change in total quantity of inputs used. And we're assuming that our input market we're assuming that the input market is perfectly competitive. We're assuming that the labor market is perfectly competitive. So that means that the supply curve facing the individual firm, this is the input supply curve, supply curve for individual firm, it's horizontal. I mean, it's perfectly elastic. And the marginal revenue product curve, this is the demand curve. This is the demand curve. This is the input demand curve for a firm. And so our point of intersection is at this point E here. So our optimal quantity of input that the firm should purchase is the point where these two curves intersect. We can easily kind of check this, because if the quantity of input is less than 12, marginal revenue product exceeds marginal factor cost. So we can increase our total profits by using more labor and producing more product and selling it up to 12 units. And in this section here, marginal factor cost is greater than marginal revenue product, so we can increase our net income by reducing the quantity of input, because our cost, marginal cost, exceeds our marginal revenue. So that pushes us to this equilibrium point of 12 units. And that kind of brings us to the next principle, that our optimal quantity of input that we should hire is at the point where marginal revenue product equals marginal factor cost. And this principle applies to all inputs. It's not just labor, but this chapter just uses labor as the as an example. Okay. So this says the same thing. The marginal revenue product curve, this is the input demand curve. This is the input demand curve for any particular firm. And the marginal factor cost curve is the supply curve. It is the supply curve for the input facing an individual firm, assuming that the input market is perfectly competitive. Okay, so we see the same point that we saw before. Our optimal quantity of input that we should purchase is the point where marginal revenue product equals marginal factor cost. And again, if we hired less than this quantity, marginal revenue is greater than marginal cost, therefore we should hire more. And in this section here, marginal cost exceeds marginal revenue, therefore we should reduce the quantity that we hire to reduce our losses, and that pushes us to this equilibrium point of optimal point being where marginal revenue product equals marginal factor cost. Okay. So in this chapter, we're looking at input markets, and input markets are a bit different than output markets, because in the output market, the demand for products is desired by consumers. And when consumers buy a product, that's effectively the end of the line of the product. That's the end of the life of the product. But input markets are different, because firms buy inputs not for the purpose of consuming them, but firms buy inputs for the purpose of producing outputs. And so the demand for the input depends on the customer demand for the corresponding output. So our demand curve, this marginal revenue product curve, is the input demand curve. So I should phrase it, input demand curve. And we saw before that marginal revenue product equals output price times the marginal physical product of the input. So if the price of the output changes, then our marginal revenue product also changes, and then so our demand curve for the input also shifts. So in the example here, so our starting point is marginal revenue product curve number 1, and then our output price declines. So as our output price declines, our marginal revenue product for the corresponding for the inputs also decline, and the marginal revenue product curve, or the demand curve for the input, is also going to decline. And if the price of the output increases, then our marginal revenue product is also going to increase, and so the demand curve for the input is going to increase. So that's what this little diagram illustrates. Okay, so next we want to illustrate the effect of changes in input prices on the input demand curve. So this is input markets, input demand curve for an individual firm and for the industry as a whole. So we want to see the impact on the input demand curve from a change in the price of the input. So if the price of the input declines, we know that the law of demand says price and quantity demanded are inversely related. So in the market, our starting point here is a price of 20, and our equilibrium quantity in the whole industry is 2,000 units of labor, and for the individual firm, it's 10 units of labor. So if the price of the input declines from $20 down to $10, then the quantity demanded in the industry is going to increase. That's the law of demand. So as the quantity of as the price of our input declines in our output market, here's our demand curve, here's our original supply curve, and then as the price of the input declines, the cost to the individual firm declines, so the supply curve for the industry as a whole shifts out. And as the supply curve for the industry as a whole shifts out, the equilibrium price declines from P1 down to P2. And as the price of the output declines, our marginal revenue product for the input also declines, because marginal revenue product for the input equals the price of the output times the marginal physical product of the input. So when the price of the input declines, we have two effects. We have change in quantity demanded of the input, so that's moving along the demand curve. And then when the supply curve for the output supply curve for the industry shifts out and the price of the output declines, and that reduces the marginal physical product for each individual firm, then we have a change in demand for the input by each firm. And so the demand curve for each firm shifts left. And so the change in quantity, the ultimate change in quantity for the individual firm, yes, it increases, but not as much as we originally anticipated, because we had the second stage impact. Okay, so let's just move on. It's a bit complicated because there's a two-step process there, but what the heck. Sorry. Okay. So we have four factors that affect the horizontal location of the input demand curve. So the first one is, we have four factors affecting the horizontal location of the input demand curve. Firstly is changes in demand for the final product. So if here's the output market, and here's our supply curve, here's demand for the output, demand number 1 and demand number 2. So if output demand increases, then our output price is going to increase, P2, and that's going to cause a shift in the input market demand curve in the same direction, D1, D2. So if so the demand curve for inputs shift in the same direction as shifts in the demand for outputs. That's rule number 1. Okay, the second factor that can affect the horizontal location of the input demand curve is the level of productivity of the input. So if input productivity increases, so here's our demand curve for labor, this input. If labor becomes more productive, then firms are going to increase their demand for the input. So the demand for the input moves in the same direction as the change in input productivity. And changes in productivity in the labor market can be increased due to technological improvements, having more of other inputs to use, or to improvements in labor quality. So if workers undertake training or they gain more experience, then their productivity can increase. Okay, so the third factor that can affect the horizontal location of the demand curve for the input is changes in prices of related factors. So this can either be substitute products or substitute inputs, or complementary inputs. Okay, so as we'd kind of expect, the demand curve for the input moves in the same direction as the price of a substitute. So if we have labor and capital and we say they're substitutes, and here's input, and let's say it's labor, if the price of capital, if the price of equipment increases, then the firm is going to want to use more labor instead, and so the demand curve for labor will shift outwards. And then kind of conversely, the demand curve for the input will shift in the opposite direction as changes in the price of complementary inputs. So if we have to use two inputs together and the price of one of them increases, that's going to make the pair more expensive to use, and so the firm's going to want to use less of the complementary input, the original input and the complementary input. Okay, and the final little section in this initial section deals with elasticity of demand for inputs. So the concept of elasticity, price elasticity of demand applies equally to inputs as it did for outputs. So we have the same definitions of elasticity, price elasticity of demand applying to inputs. So it's the same definition that we saw back in chapters, I think 4 or chapter 6. Price elasticity of demand is change in quantity of demanded divided by the change in price. So if the price elasticity is elastic, then the ratio is greater than 1. If the price elasticity of demand is inelastic, the ratio is less than 1. And if the price elasticity of demand is unitary, then the ratio equals 1. Okay, so we have these four factors affecting the price elasticity of demand for inputs. So the price elasticity of demand for an input is higher, the greater the price elasticity of demand for the final product. So if the price elasticity of demand for the final product is elastic, so in our output market, if the demand curve is fairly shallow almost horizontal, and the price of an input increases, then the firm is not going to be able to pass that price increase on to its customers, because that'll end up with a large change in quantity supplied in the output market. So there's an impact on the price elasticity of demand of the input, of the output on the input. Okay, so the second influence of the price elasticity of demand for inputs, so is how easy it is for the input to be substituted by another input. So the price elasticity of demand for an input is higher if it's easy for an input to be substituted by another input. An example from the book is if glass and plastic for food containers are substitute inputs, then the price increase in either one of them will reduce the quantity demanded for that one and it'll increase the demand for the other. Okay, third factor is the portion of total costs that the input occupies. So if the input constitutes a large portion of total costs, then a large price increase in that input will significantly reduce the firm's demand for that input, because they're going to want to shift it from that input to another input. But if the total portion of total cost of a particular input is small, then even if there are large price increases for that input, the firm probably won't substitute out of it very much, because it's not going to affect the total cost very much. And then the final factor is how long does the firm have to adjust to the change in the price of the input. So the more time the firm has to adjust to change in the price, then the more elastic the demand will be for that input. Okay, I'm going to do a separate video for the next section. So that's it for this first section.